Yes, sir.
Okay, so again, once again, good afternoon, good day. We are now on lesson 4, that is kinetics of rectilinear translation, that is analysis as a particle. So in this lesson, we considered a body as a particle, or an object as a particle, not a body. So by the end of this lesson, you will be able to apply the D'Alembert's principles in kinematics and kinetics in analyzing and solving system of bodies undergoing rectilinear translation. So this time, uh, we are we are going to consider the forces that acts in our system of bodies. Okay, system of bodies. So let's start with the kinetics behind the rectilinear translation for rigid bodies. So on the left picture, so uh, we have here a body represented by this oval, and then an object, no, represented by this oval shape, and we all know that an object is composed of several particles. So we have here particle number 1, particle number 2, particle number 3, particle number 4. And then this red arrow shows the direction of motion. So the mechanics behind this one, or the laws in analyzing the rectilinear motion of rigid bodies, is that all the particles, no, that comprise the body moves parallel to each other. So particle 1 moves towards the right, which is parallel to the movement of particle 2, and also particle 3 and particle 4. Additionally, no, this particle, the direction of motion of these particles are also parallel to the direction of motion of this entire object. Okay, of this entire object. So this is the first rule when we analyze the motion, or the rectilinear motion of rigid bodies. The second one, okay, before we proceed to the second one, additional information with regards to the first rule is that the velocities, I I think we already I already discussed this one to you. No, that the velocities for all particles are the same. Let's say for the first particle, natay velocity nga v1. For the second, still, this is v2, but v2 is equal to v1. And for v3, still equal to v2. So meaning to say, all the particles have the same value for their velocity, displacement, as well as the acceleration. In the second picture, we have here a same object represented by this oval. And then in order to simplify our analysis, so we just pick a single particle that would represent this entire object. No, whatever the size of the object, we just consider this one as a particle, not a body that comprises of several particles. Because if we consider all the particles, it's nonsense, because all the particles that compose or comprises this object, they have the same values for the velocities, displacement, and acceleration. So let's just pick one, and that particle should be located at the center of gravity, no, at the center of the object. So this one right here. Okay, so let's just consider one. And then the second rule states that all forces interacting the body will be concentrated at the center of gravity. Say for example, in this picture, so if this object is influenced by these three forces labeled P1, acting at the upper part, P2 somewhere in the middle, and then P3 somewhere below. So if we sum up these forces, the resultant should act at the center of gravity, okay? Or it will be concentrated at the center of gravity. And that resultant, no, that resultant would produce, okay, an acceleration. So that is why we relate the resultant force to the mass of this object and its corresponding acceleration. So if this object accelerates, we can say that its velocity changes. It could be increasing or decreasing. Okay, given that it has a resultant force. Okay, let's say no one resists the concentrated force at the center of gravity. So if no force, no, nga capable to resist the resultant force at the center of gravity, then this object uh, would move towards the right. Okay. So the third thing is that when we are going to solve a system of rigid bodies ng mga problems, um, ato lang i-take into consider the summation of forces, because here we're not talking only about the kinematics of the rigid bodies but also the kinetics. So remember, in our previous lesson, I discussed to you the difference between kinetics and kinematics. So if we talk about kinetics, we are considering the effects of external forces. So here, let's just say that this object moves on a single direction, and then we consider that direction, or we let that direction as the x direction. Okay, we can also choose other directions, no, as long as one direction lang. Okay, so you can choose either on the y axis alone or the z axis, but in this picture, after you consider, let's consider that this object, okay, by the basis of rectilinear translation, dapat usa lang ang iyahap direction, that is along the x-axis. Now, if this is the thing, then if we take summation of forces along this direction or along its path of travel, then all the forces that interact should be equal to the mass of this object. This is the general representation, no? I put here weight over g, so that you not get confused, no, if you are dealing with English nga mga English units, no. So this one is still equal to the mass m. Okay, so don't worry. So that is equal to the mass times the acceleration. And the second one, uh in your analysis, no, or in your solution, part of your solution is that you're going to let also the summation of all forces from the other direction to be zero. Okay, so here I put here summation of forces along y is equal to the summation of forces along z, in which both of them are equal to zero, meaning there is no movement on the other axis. Okay, this is the third law. So don't forget these three principles, because it is useful in analyzing problems related to rigid bodies. So next, let's discuss on the general steps in solving kinetics problem for rigid body system. So these steps uh, may not be sequential, no, in your part. Maybe there are some kuan-ani steps nga mag-una, so it depends upon your upon your preference. But this is just a guide, no. You can also follow this one. So the first step is you need to draw an FBD grid. So FBD stands for free body diagram. So it shows um, the object, but in some FBD, they only represent the object as a single dot. So meaning to say, uh, ihag-represent ang object into a particle, no? In order to simplify the illustration. And after drawing the FBD, you should determine the known and unknown forces. So let's have here an example. No, this we have here a block resting on this horizontal plane. So assuming that the block has a weight, so if we're going to draw its FBD, you can also consider this block as a particle. So just a dot, no? And then the forces that interacts this one, the first obvious nga force is its weight, no? May weight siya, weight W, okay? And then, of course, since it rests on the top of the surface, so the surface exerts a normal force N. And then let's assume lang that there is an external force that acts this block towards the right, no? Na siya P. Okay? So ato ikon ngadto, aday nga part, sorry. So we have an external force P, and let's consider that this is a real surface. So if that is a real surface, then the friction is present. So again, friction, we don't know yet if asaya direction, no? So let's say the friction acts along the horizontal plane. Okay? Don't worry, ato na siya baliko, no? If we are through with the second step. So as long as you know the known forces and also the unknown forces, then your FBD is already good. Now the second one, after having the FBD, no, you should determine the direction of motion, if not evident or specified, and mark it on your FBD. So there are some problems nga given ang direction of motion, but there are some that is not kanang wala siya gihatag, no, not obvious. So it's okay to assume, no, to assume a direction of motion. Kay at the end, no, the only thing that would differ uh, sa imong answer from the true answer is the sign lang, okay? As long as your sign for all the forces are consistent, then the only difference between your answer and the true answer is only the sign. So if it is negative, then your assumption is opposite, no, to the true direction of motion. So here, let's say for example, no, this block will move towards the right. So you should indicate, no, this is the direction of motion. So the direction of motion also tells us where does this object accelerates. So if this is towards the right, no, so the normal convention of the direction of acceleration is towards the right. But with the Alembert's principle, that is in reality, that is the reverse, no, the reverse. So ay mo ma-feel if mo accelerate ka, let's say the direction of motion is towards the right, ang imong ma-feel in the real scenario is towards the left, no? That is explained by the Lambert's principle. Well, anyways, in our calculation, let's consider the conventional the conventional method lang, that is the direction of the acceleration is uh, equal to the direction of motion. Okay? So in step 2, don't forget that the direction daw of the frictional force is opposite from that of the object's motion. So if the direction of motion is towards the right, then it is expected that our friction is towards the left. So F. Okay, so this is our frictional force directed towards the left because our direction of motion is towards the right. So in layman's term, yung friction mo na siya magpugong, no? Mo na magpugong sa pag-move sa ato ang object. So the third step, no, we have here some I have here some formulas sa kinematics. So don't forget those formulas because we are going to use these formulas in solving rigid body system. And then for number 4, you should select the x-axis. So it is not necessarily an x-axis. So you can also use x-axis, or you can also use your own axis, no? Because it depends upon the illustration of the problem, no? There are some problems that the axis is inclined with respect to the horizontal. So you can also you can also let that one into another letter aside from x. So you can have, let's say, along xx or along a plane, depends upon you, no? Pero if you want to follow the kuan, the standard set by some books, so you can have this x-axis. Okay, so select the x-axis as positive in the direction of motion. So earlier, we already have the direction of motion for our object here, so that is towards the right. So direction of motion, so meaning this is our axis of interest, x-axis. So ang pasabot ang aning number 4 is that if the force is directed towards the right, that is a positive force, no? So otherwise, if it is directed towards the left, then it takes the negative side. And afterwards, so apply the two kinetics equation. So first is yung summation of y and summation of z should be equal to 0, because again, in solving these kind of problems, um, the other two remaining directions uh, should be neglected, no, in terms of the forces that interacts uh, along that kanang direction. It's because we were only considering a body that moves on a single axis or on a single direction. So no rotation, no translation with respect to other uh, axes. Okay, so you can use this one. And then finally, so solve for the unknowns. So using such additional equations of kinematics as may be required to determine the relations between the displacement, velocity, I forgot the acceleration here, and also the time. Okay. So again, first step, don't forget FBD. Second step, don't forget to indicate the direction of motion, and also consider the direction of the frictional force that is always opposite to the direction of motion. And then the third one is, don't forget those formulas from our kinematics nga lesson. Okay, just the three, no, just the three. So I've already discussed that one. I'll show you I've already shown to you the derivation using differential equation. And then the fourth one is um perform the two the two kinetics equation, no? That is, you take summation of forces along the x axis. So that axis um is your standard axis, that is the axis of the direction of your motion. And then the second one is you equate the summation of forces on the other axis to be 0. Okay. And then number 5, of course, do the math, solve for the requirement of the problem, or solve for the unknowns as required. So any question with regards to the general steps? Wala ra? Okay. So let's have problem number 1. So an elevator daw weighing 3,220 pounds starts from rest, and acquires an upward velocity of 600 feet per minute in a distance of 20 feet. I have here a figure. So for you to visualize what is happening in this problem. So if the acceleration is constant, what is the tension in the elevator cable? So if the problem uh, states some forces now like tension, so we are going to use kinetics equation. Okay, so that is why um, dapat naka-FBD and you know how to determine the forces that interacts our object. So our object here is the elevator. So since all the particles or all the parts of the elevator uh, has the same velocity as it travels, so atola siya considered as a particle situated at its center of gravity by this dot. So first is we're going to write the given. No? We have the mass of the elevator expressed in English unit 3 to 20 pounds. We also have the um, final velocity. Okay, final velocity 600 fpm. Fpm stands for feet per minute. And then we also have the displacement from the problem that is at 20 feet. Okay, so the requirement here is we're going to solve for the tension, no, sa rope. So where does this tension located in our drawing? So this one, this vertical line represents the rope that is used in this elevator to lift this elevator. So the tension, para siya. Okay. So the first step is um, we need to draft, no, or we need to create an FBD. So first, FBD of the elevator. FBD ng ating elevator. So what we did here is the kinetics part, no. So when you say kinetics, we are to consider the forces that interacts our system. So again, for our elevator is an object. In our FBD, let's represent our elevator in a single particle. So that lang. Okay. And then what are the forces that interact our elevator? First is its own weight. Okay. So we can represent that one as W. Okay. And then next is syempre gi-lift man siya, no? So na tension sa rope. And then what else? So after having this FBD, we need to indicate the direction of motion. So the direction of motion is upwards, yeah. Okay, gi-lift man. So therefore, that is also the direction of our acceleration. So there is no friction because uh, it was not stated in the problem, meaning gi-neglect ang air resistance and also the friction that exists between the elevator and the railings, no? And the railings. So wala man. So no friction. So after having this FBD, then we're now ready to take a summation of forces. So solving for T. So we take summation forces in a single axis alone. So yung axis natin dito, usara, no? Vertical axis lang. So what? Summation forces vertical should be equal to, again, the Allenbert's principle, equal to the acceleration of this elevator. So that is the mass of the elevator times its acceleration. Now you should initialize the sign convention. So positive siya if along siya sa direction of motion. So along upward. So what are the or what is or are the um, upward forces? So only tension. So tension minus the weight na. So the weight has a minus sign because it is directed downward. So equal to mass times acceleration. Our weight can be expressed as mass times gravity. Okay, so tension minus mass times gravity equals mass times acceleration. Mass is given. G, that is constant. We already know that one. In English, that is 32.2. However, we don't have acceleration. Okay? We don't have acceleration. That is why, aside from the FBD of the elevator, we need to illustrate also the kinematics behind this elevator. So that is why dili na to i-ignore ang kinematics nga part. So for the kinematics, okay, kinematics. For the kinematics, so let's consider the initial state and the final state of the elevator. So initially, nag-start siya at the bottom. Okay? So let's label this one as the I state, stands for the initial state. And then when it reaches the height of 20 feet, that is the final state. So represent lang natin F. So at initial state, of course, it has an initial velocity. However, it doesn't have a value because from the problem, sabi dito, it starts from rest. So 0 FPM. Now, for the final velocity, given siya 600, no? FPM. Okay? And then sir, gilift man ni siya. So uh, is this problem belongs to free fall? Actually, this one is not belong to free fall because there are some forces that interacts our object, no, unlike in our free fall nga discussion, no outside forces interacts, just the ko ano the object alone travels along the air, no, then reaches its maximum height and then falls back towards the earth's surface. So here hindi mag-apply ang free fall, but mag-apply diri ang rectilinear translation. So it has an acceleration A upwards. Okay? Dili G ha, dili G because na may forces nga nag-interact niya. Mao nang dili na G ang iya. If walay force nga nag-interact niya, then assume na to nga free fall. So A, we have initial velocity, final A, and we have displacement, no? 20 feet. This is our displacement delta x. So to solve for A, we're going to use the third kinematic equation, no? Solving for A, that is, the third kinematics equation states that the square of the final velocity is equal to the square of the initial velocity plus, so I take the positive sign, it's because the direction of the acceleration is also the same with the direction of motion, that is upwards, and also the displacement, positive displacement siya. So 2A change in, actually this is not change in x, no, because this is not on the x direction, pa upwards man siya. So let's just change this one into y. So 2A change in y. Now we all know that initial velocity is 0, so 0 na. Solving for A is just v final square all over twice the displacement. Okay, so that is 600, and then let me convert the minute to second, no, that is feet per minute. So I divide 60, and then 2 times the height is 20. Okay, so our acceleration, we're going to use our calculator. So that is, ay sorry, naka stat mode siya. So we have 600 divided by 60 square. Tapos 2 times 20. That is 2.5. So the acceleration is 2.5 feet per second square. So we're going to use this value to solve for the tension. So the tension is equal to, we can transpose the weight on towards the right side. So may mo siyang mg plus ma. So we can factor out m, mass, that is, so as you notice class, um, this is in pounds. So kanang this is different from the English, no? I mean metric. So the mg can be represented by the weight, no? Weight. So ato lang siya i-represent as a weight. Kay if natay pounds dira ato bigid multiplyan og g nga 32.2 feet per second, manubra na ang ato ang kuano, because in English sometimes maget confused ano sa pound mass and pound force. So ato la i-weight, tapos on the other side weight over g. Okay? So why is it nga na g? So that ma-cancel out ang unit for the acceleration. So i-factor out nato, no? Again, m, we can also represent this one as weight, no? Because this is English unit. So that is 1 plus a g. Okay? And the next, ato i-substitute. So 3 to 20 tapos 1 plus, this is 2.5 divided by 32.2. So that is the standard acceleration due to gravity. So therefore our tension, no, ang atong tension is equal to 3 to 20, 1 plus 2.5 divided by 32.2. Okay? So the answer is 3470. So 3470, so that is pounds. This is the tension of the rope. Okay? So as you can observe, the value of the tension is larger than the weight of the elevator itself. So asa man nagikan ang sobra, ang excess. So ang sobra galing na siya sa acceleration. So if wala pa lang na nag-move atong kuan, ato ang elevator, the tension is just equal to the weight. But if it moves upward, no, syempre maka-feel siya og bugat, no, due to the effect of the acceleration of the elevator. There is an inertia that takes place. Okay, so any question with regards to our first problem? Okay, sige, sige. Wala gilabot ang friction. It's because wala man gi-indicate po sa problem, wala man siya ningon nga na ay air resistance. So mostly ang friction gyud nga mo occur aning elevator nato is first is air resistance, no? Syempre namo ginay air that surrounds our elevator. So since there is no statement in the problem that say that we need to consider the air resistance, so wala man. So no friction from the air. Second one, we can also have a friction between the body of the elevator and the railings, no? Kana iyahang guide ba or kaning poste, no? Ako lang gi-show sa illustration. So since it is not stated, no, that there is a coefficient of friction that exists, or friction that exists between the elevator body and the railings, no, wala man say coefficient of friction nga given, so it is understood that friction here is neglected. Okay, so mana inyong indication, umaklo. Okay. Actually, if labuton ang normal force araa, pwede pod. However, um, it does not affect, no? It does not affect the kuan, the calculation, because say for example, if you include that one in your FBD, no? Ano si normal force, no? Good thing ngay mo nagi question kay, let's say kaning elevator kay mi rest ni siya significantly sa kaning ihang railings, so there should be a normal force, no? However, in our analysis, no, we only consider the summation of forces along the vertical axis, not the horizontal. So the normal force is not needed in our calculation. Okay, so be mindful lang ato, and always remember that the summation of forces from the other axis should be equal to zero. So more or less, they are not included during the calculation, no, or during the analysis. Maybe there are some in the second problem, no, in the second problem, the information from the other axis will be useful, no, especially if we're dealing with friction, because friction is related to the force that acts normally to the surface, no. So dira na to magamit in the second problem. For the first problem, the normal acceleration here is neglected and not needed in our solution, but in the second problem, useful na siya, so ato kitaan. But before proceeding to the second problem, na pa ba yung mga questions? Ang uban, napay pangutana? Okay, so let's proceed to the second problem. So we have here a system of rigid bodies. We have three objects here: object A, object B, and this 300-pound object that is hanging in this pulley. So the coefficient daw of kinetic friction under block A in the figure below is 0.3. So again, for problem number 2, meron ng friction. So for A at the surface, 0.3 ang iha coefficient of friction. For block B and the surface, 0.2. So the requirement here is the acceleration of this system and also the tension in each chord. So if the two objects are connected by via a single cord, and then assuming that the the pulley right here is frictionless, then we can say that the tension on this side and also on this side are equal. So we can let this one as T2, no? That is for the second chord, and let's consider this one as T1 for the first chord. Okay? So we have two tensions, and these are unknown, and these are one of the requirements. Again, let's just write the given first. So first one is the coefficient of friction for block A. So mu lang, mu A, that is 0.3. Tapos mu B is equal to 0.2. So from these two values, we can say that friction that exists between block A and the surface is greater than the friction that exists between block B and the surface because of their values. What else? Natay given nga mass, no? That is in English, so be mindful. Mass A or weight A is 100 pounds, mass B is equals to 200 pounds. And then we have the third mass, 300 pounds. And the surface for both blocks A and B are inclined 30 degrees. So to solve for this one, again, don't forget to illustrate, or don't forget to create an FBD. So since we have three, no, three objects, so it is expected that you should create three FBDs. So let's start with block A. So FBD at block A. That is why I I highlighted, no, the uh, the static analysis in this kind of problem during our statics review, because that is very useful in our discussion for today, no, kanisiya. So if you're good enough, no, sa katoatoang kuan, if you really study those lessons, then in our discussion for today, it would be easier. Naalay gamay nga i-add diri ano. So ang kanang gamay nga to i-add, that is the acceleration, because in statics, stationary lang ang mga blocks nato ato. However, in our discussion for today, our blocks nag-travel na sila. So there is movement. So assume lang ta. I forgot to assume that the direction of motion. So let's assume that this system of rigid bodies will move downward, no? Paana siya. Not towards, down the inclined plane, but in this direction. So meaning the acceleration is in this direction. So kaning red arrow, no? Padaw na siya, mahatak na siya. You can also assume on the other direction, no? So it's up to you. As long as you follow those rules and those steps in generating the FBD. So first, for block A. So again, considered block A as a particle lang. So dot. Tapos, what are the forces that interacts block A? First is its own weight directed downwards, 100. What else? Syempre, it acts normal to this surface. So we need to resolve this weight into components normal to the surface. Okay, this one is 30 degrees, no? And also along the surface. So along the surface, this is a right triangle. So this is 100 sine 30. Okay, right triangle atong na-create no? And also this one 100. This is 100 cosine 30 degrees. So ato lang gi-resolve si 100 nga weight into its components along the surface and normal to the surface. What else? So we have a normal force, and then we have a tension, no, sa first rope. So tension, padong siya sa pa-up siya, no. What else? So since the direction of motion is towards the towards the um right, upwards to the right. So therefore, opposite si friction. So si friction paana po siya. So this is the first friction, F1. Okay? So indicate the direction of motion. So pangato ang direction of motion. Okay? That is also the direction of acceleration. So here, we are already through with the FBD. So our axis here is the inclined plane, no? The axis here is the inclined plane. Ato so ato i-label nga axis XX lang. So summation forces along the axis XX. So in choosing the axis, it should be along the direction of motion. So that is equal to, again, the mass of the block A, that is 100, but since that is in English, so divide siya by G. the value of G is 32.2 times the acceleration. Okay? So, sign convention, positive atong forces if it directs upward towards the right. So, unsa may mga upward forces towards the right? We only have T1. So, T1, the rest is pa downward na siya. So, we have the friction and also the component of the weight. So, minus 100 sine 30 degrees minus the friction, okay, is equal to, again, 132.2 times acceleration. But kay bawo man ta, we all know that friction is equal to mu A, since this is block A, and the normal force acting on the block A. Okay, NA lang na siya. And then, if we take summation of forces, no, along the normal axis sa aning nga surface, no, summation of forces along the normal, again, ato na siya is zero. Okay? Mo na akong gingon dito, summation of forces on a different axis should be equal to zero. So, meaning to say, the normal force is just equal to the normal component of the weight. So, normal force A is just equal to 100 cosine of 30. So, ato na siya i-plug in diriya. So, we have T1 minus 100 sine 30 degrees minus we have 100. Our mu A is 0.3. Tapos cosine 30 degrees equals 100 all over 32.2 times the A. Ato siya i-simplify further. We factor out 100. So, 100 times sine of 30 degrees minus 0.3. This is plus di ay. Kaya factor out pa ng negative. Plus cosine 30 degrees close is equal to 100 all over 32.2 times acceleration. So, this is our first equation. So, don't forget this one. So, proceed to the next slide for the FBD for block B. So, FBD for block B. So again, let's consider object B as a particle. Then, what are the forces that interacts our particle B? So, iyahang weight, that is 200. Ato i-resolve yung components, that is perpendicular and parallel to the surface of the inclined plane. So, this is 30 degrees. So, we have 200. This is sine 30. Then we also have here 200. This is cosine 30 degrees. So, again, ato ikuan suwat dito, this is T1, this is the direction of motion, then this is the axis XX. Okay, so in block B naatay T2 nga tension. Okay, and then below syempre nibira pod ni kaning first nga rope, so we have T1, and aside from T1 we also have our second frictional force, no, we have F2. Okay, my friction man. And finally, the normal force. So the normal force that acts our block B. Okay. So again, this is the direction of our motion and also our acceleration up the inclined plane. So summation forces along axis XX should be equal to the mass of block B. So that is 200 all over 32.2. Okay. Times acceleration. Same lang po na acceleration si A and B because they are connected via this rope. which is not flexible, which is not elastic, no? So assume mo na siya. And then next, take positive if it is directed upwards up to the inclined plane. So unsa may force ra nga upward, only tension 2. So tension 2 minus tension 1 minus the friction minus the component of the weight, that is equal to 232.2 times the acceleration. Again, we all know that um, the second friction is also equal to mu b times the normal force at B. And then if we take summation forces along the normal surface, that should be equal to 0 based on our rule kaganiha ako explain. That is why the normal force B is simply equal to the normal component of our weight. So 200 cosine 30 degrees. This one, okay? Pareha na. So therefore, we have T2 minus T1 minus our F2 is 200 times iyahang value for coefficient, that is 0.2 times cosine of 30 degrees minus 200 sine of 30 degrees. This is equal to 200 all over 32.2 times the acceleration. So if we simplify this, the final form of our second equation is T2 minus T1 minus 200. Factor out, we have sine 30 degrees plus zero point 0.2 cosine 30 degrees is equal to 200 all over 32.2 times the acceleration. So this is our second equation. So for the next slide, let's proceed to the final object, kanang hanging object, kanang 300 pounds. So for the third part, FBD for 300-pound block. So let's consider that one as a particle. The forces that interacts, again T2, T1. So the direction of motion for the 300 pound pa downward na siya. So ang downward forces usa lang di ay ang weight, so 300. And then there's a tension sa second rope. Okay? So the direction of motion is downward. The acceleration is downward. So we take summation, no? Summation forces along y or along the vertical should be equal to the mass, that is 300 over 32.2 times its acceleration. So here we take positive if downward. So nganong downward man, sir? Because that is the direction of our motion. So we need to follow the direction of our motion. So unsa man ang mga downward force, usa raman, so 300 ra. So write 300 minus T2. So subtract si T2 kay pa-upward man siya. Is equal to 300 all over 2.2 times the acceleration. So this is our third acceleration. So the final step is we're going to combine those equations. So first, for equation 1, ato i-arrange siya in a sense that we need to start sa first unknown T1 followed by the second unknown T2 and the last unknown, the acceleration. So this is how we're going to arrange those three equations. So starting with equation 1, going back sa ato ang previous slides. So kani siya. Okay? So ato i-transfer diri we have T1 T1 plus, since sa first equation we don't have values for T2, so 0 lang, 0 T2. For acceleration, ato to siya i-transpose. So, mahimong minus 100, 32.2 times acceleration. So, if we go back to our slides, this one, gi-transpose lang, and the constant, gi-transpose on the other side. So, that is y equals 100. This is sine 30 degrees plus 0.3 cosine 30 degrees. So, this is our equation 1, modified na. For the second equation, again, negative yung T1, T2 positive. So, negative T1 plus T2. Tapos, the acceleration, just transfer this one on the other side and also the constant on the other side. So, we have minus 200. 32.2 acceleration is equal to 200. Tapos, sine 30 degrees plus 0.2 cosine 30 degrees. This is our second equation. On the third equation, we don't have T1 here, so 0 T1. Now, we can multiply both sides by negative and then transpose this one, and also this one. So, the resulting would be positive T2, so plus T2. Then, if we multiply, if we transpose this one mag-negative, times negative, so positive then. So, plus 300 all over 32.2 A is equal to, if we transpose this one on the other side, mag-negative times negative, so positive. So, equal to 300. This is our third equation. So, if we have three unknowns, T1, T2, and acceleration, and we also have three equations, then we can solve this one using our cycle. Okay? So, T1, T2, and the acceleration. So, using our cycle, we need to input these three equations. So, go to mode, press equation 5, choose number 2 for three equations, three unknowns. So, just type the coefficients. So, for T1, that is for A, so 1 lang. For T2, 0. For acceleration, that is negative 100 divided by 32.2. Then for the constant, this one. So, be careful with the parentheses. Make sure that that is in degree mode. So, naka-degree mode na ni D. So, input sine 30 plus 0.3 tapos cosine of 30 double parenthesis equals. In the second equation, we have negative 141. T2 is positive 1. Tapos acceleration negative 200 divided by 32.2. For the constant, we have 200 times sine 30 plus 0.2 cosine 30. Okay, so equal sign. For the final equation, 0 si T1, positive 1 si T2, tapos 300 divided by 32.2 si acceleration, and then we have 300 as the constant. Then another press ni ang equal sign. So the T1 is approximately 90.88. So approximately 90.88 pounds. Then for T2, press equal again, 255.31. So 255.31 pounds. And then for the acceleration, i-press na pag equal, 4.8. No? Approximately 4.8. This is in feet per second square. So these are our answers. Okay. So any question? Any question, class, so far? Okay, sige. But before sa question, let me end this kaning ato ang recording, no.